Hey you guys, in this lesson we're going to look at some surface area problems including some composite areas and also some volume problems including cones and cylinders, and we'll also look at some equation manipulation. So thanks for watching. Don't forget to like, comment, and subscribe. The area of rectangles. The area of a rectangle is length times width. This is pretty generally known. So this would be considered a rectangle. Just so you understand, because some math people get really picky about the terminology here, length is generally the longer of the two sides, and width is generally the shorter of the two sides. So even if I took this and, well, I just kind of switched it, right? Something like this. So it's not about position, it's about length. Length is the longer side, and width is the shorter. Now, I only tell you that because you may have a professor someday that marks stuff wrong because you've made the width the longer of the two sides. I don't care. So it asks what the height is. So they didn't even use length or width, jerks. What is the height of the rectangle? I guess that's nice. They did show us this is the missing value there. I'm going to use x because x is nice. What is the height of the rectangle if the area is 345 square feet? All right, well, let's look at what we know about rectangles. Rectangles is length times width, and that would equal our area. Now, if you did area equals length times width, it's not going to matter. Well, here's what we know about length is, if we consider that the longer of the two sides. The longer of the two sides is 23 feet, or apparently. What we don't know is the width or the height, so if you wanted to change that to h, feel free to do that, all right? What we also know on this is the area, because they told us the area is 345 square feet. So 23 times something is 345, and this is just a basic equation which we can divide both sides by 23 to solve. And that will give us the height. This one came out pretty nice, 15. Just be careful. This is a measurement, right? So don't forget to label this in feet. The height is 15 feet. Find the area of this composite shape. The composite shape just is two shapes or more kind of pushed together. In this case, we have two rectangles. Some of you are seeing these two rectangles. Some of you are seeing these two rectangles, and it doesn't matter which two you see, as long as you can figure out the area of both of them. Oh, sorry, there is another one. Some of you guys are seeing this rectangle. Now, again, it doesn't matter which one you're seeing, as long as you're calculating it correctly. The question, though, is which one do you guys want me to use? Then it's unanimous. We will use the one that probably no one is using, this one. Okay. Now, let me just show this. I'm going to ignore these lines right here, so we'll just make them dashed. That's kind of pretty. So now we can see this as one large rectangle, right? So what I'm going to do is figure out the area of this full large rectangle, which has a length of 9.8 feet. And I'm going to multiply it by the height, or the width, whatever you want, which is 10.1. This will give me the area of that red rectangle. The problem is I've got this other rectangle right here, which I just need to subtract off of it. All right? So what are the dimensions of that rectangle? Well, if that's 3.5 and the whole thing is 10.1, then this measurement would be 10.1 minus 3.5. So that's, by the way, is just the height of this thing. I also need the width of it, right? So the whole thing, if we looked across, would be 9.8. However, we're not going that far. We're just going this far. So we got to take off that 4.8. So I've got 9.8 minus the 4.8. Minus. So this would be 5 feet right here. So this is a 5 by 6.6 rectangle. So I've got a width of 5 times the length of 6.6. Now this purple rectangle never existed, right? If we look back at the problem. So I do need to subtract that off of the 98.98.
So the whole area of that composite shape was 65.98, but that's area, right? So we got square feet. Now I just wrote that differently than I wrote the last one. It wouldn't matter because it represents the same thing. This 65.98 square feet is the same thing as this 65.98 square feet. It's just written differently, that's all. In this example, though, we will be doing the addition method. So I'm going to break this up into two separate shapes. I've got a triangle. Now that's shown as two triangles. It's just showing that this length right here is 5. Otherwise, we don't really need that line right there, all right? So I've got two shapes. I've got a rectangle. It kind of looks like a square. And also a triangle. Well, all right, let's find the area of the rectangle, and again, I'll just add it to whatever the area of that triangle is, and we'll figure that out. So I've got length, 10, times the width, 8. So this one is 80, didn't tell us the units, so that's fine. If you wanted to put square units, that's fine as well. But since they didn't label it, it is not required that you label it. Now that was just the rectangle. Next up is this triangle. We'll just outline it in red, and then we'll combine the two. There is some memorizing on this next test, right? Now, the nice thing about triangles is triangles, let's look at any rectangle like this one. Let me draw it better. All right, so this rectangle's kind of emphasized, right? One's much longer than the other. And to find that area, you do length times width, right? However, how do we make a triangle out of a rectangle? We just cut it in half. Right there. So as it turns out, the area of a triangle, which we're looking at in red, the area of any triangle is its length times its width, which some people call height, but it's half of that because it's all triangles are really half of a rectangle or some kind of parallelogram. Well, on this one we have a length, which some people call it the base as well. I'm just going to call it the length, which in this case is that bottom length, this one, which is it's just going to match this one at the bottom here at 8. So I've got length at 8 multiplied by the height of this thing, which we can call the width, and that is this 5 right here. So I've got 8 times 5 divided by 2, which gives me a total area, if I were to plug this into a calculator, of 20 square units. Well, the triangle's 20, and the rectangle of this shape is 80. So to figure out the area of the composite shape, we're just going to add them together. 100. Well, that worked out pretty good. 100 square units if you want. That's pretty formal, though. What is the area of the square? What is the area of the circle? And what is the area of the blue section? This seems like it looks, just the picture makes it, I think, look more complicated than it is, which is why most people hate it. Let's just look at the square. So, if we were just to ignore that circle right there, then I'd have this square. They didn't label any of the sides, but they did tell us what the side lengths are. And the nice thing about this is, since it is a square, we know that the other side lengths are also 10 feet. So the area of the square would be length times the width. And that's the unique thing about a square, is that the length and width are the same. So it's really just 10 times 10. And that would give us 100. Now don't forget to label that, right? It's in feet squared. So that's just the area of the square. But we also, on the second part, want the area of the circle. So let's look at that. It's not a great circle, but whatever. The area of the circle, the area of all circles, really, is pi multiplied by the radius, and we're going to square that radius. All right. Some of you even prefer to see this as radius times radius, and I don't really care which way you like it. Just do it. All right. everyone should have a pi button on their calculator. If you don't have a calculator, get one. Because the pi button is extremely convenient. If you don't have a pi button on your calculator, just use 3.14. You know what? Let's take it to the limit. 3.1415. Yeah, there's arguments about what the actual value of pi is, and I don't really care. So, we got to figure out the radius of the circle. Now, here's the thing is we know that the diameter of this thing, if we were to go all the way across it, is the 10 feet. But we're not going all the way across. We're going from the center to any of the edges, which is half the diameter, so that's 5 feet. By the way, it wouldn't matter if you'd drawn this line either. It's still 5 feet, okay? So the area of the circle is going to be pi times the radius squared. I'll just plug that into my calculator. So I got 78.54 on that one. And yeah, let's label that in feet squared. Well, this wants the area of the blue section, which is really the area of the square if you take away the area of the circle, right? So we're gonna take out all the purple area right there. Now this may seem a little confusing, but we know right now what the area of the circle is, or in the purple there, and that's 78.54 square feet. So if I wanted the area of the blue section, I would take the area of the square at 100 square feet, and I would subtract from that the area of the circle at 78.54 square feet. So, you know, if you're going to use, not use a calculator, use place values on this thing. And there we go. Surface area of open objects. We have the area of a rectangle, which is length times width. Surface area of a box is just a bunch of rectangles put together, right? So, you know, if you like drawing or whatever, maybe you got a rectangle, and then some of you guys like to draw another rectangle. This is a box, right? So then you just connect the four corners like that. But some of you guys like to take it even further and then just show that, you know, these are dashed lines, and I don't know. I feel really good about that. However, this one is a little different. This one would represent a fully closed box, but since it's open, we got to include that line right there. Again, this is not art class, so I don't really care. But it just may help us to understand what the heck is going on this thing. This is an open box, so we can show these lines here too. And now it looks really pretty. Well, here's the thing is length, width, and height. Yeah, we got 3 dimensions for the box. We got the length and the width, and that is how you find the area of, I guess, the base is what we can call it. And then you have the height of the box as well. But the height is also over here as well. In fact, it's all 4 of those lines. So we can see from this, hopefully, that I've got this right side, which is also matching this left side. That's why we have 2 of these width heights. And then I've got the front, which also matches the back face, which is why I've got 2 length heights. And again, with the bottom piece, the bottom, the base, whatever, I've only got 1 length width, because this is an open box, open prism, whatever. Yeah, there we go. This one, they did give us the formula. The surface area of an open box, open top box, with length, width, and height can be found using this formula. Find the surface area of an open top box with length 12 centimeters, width 3 centimeters, and height 9 centimeters. So let's go ahead and write this out, just the formula that we have. All right, well, they did tell us the length was 12 centimeters. So I'm just going to go in here, and I've got this length. And I've also got this length right here. And I'm just going to replace those with 12, because that represents the height. Next up is the width at 3 centimeters. So I'm going to go in and find all my widths, only these 2. And I'm going to replace those with the 3 centimeters. And then finally, the height at 9 centimeters. All right, at this point, it is order of operations, unless you plug it into your calculator. So just multiplying these out, like if we did this multiplication first, then we can do this one right here at 54, and then this one at 36. Now this is the area, the surface area of this open top box. All we got to do now is add all these together. So when we do that, 216 plus 54 plus 36, 306. But this one did come with units, so please don't forget to label this in square centimeters. And that would be the area of this open top box. Volume of objects. Let's look at the cylinder first. Cylinders are pretty nice. So cylinder, I just got a circle on top and bottom. It's kind of like a prism with a circle as its base. In any case, you've got your height right here. And the only other measurement that we really need on this is the radius. All right. And when we do that, we can see from the volume of the cylinder that all we're really going to do here is going to take the area of this circle, which is pi times the radius squared, and then we multiply it by the height of the actual cylinder, and that would be the volume of the cylinder. All right. So that's the volume of the cylinder right here. The cone, though, some of you notice from this that the volume of the cylinder is the numerator for the volume of the cone. All that's happened is you've divided it by 3. So, if we were to draw a cone in this thing, as it turns out, you can try this at home, not that anyone will, but if you found a cone that had the same height of a cylinder with the same radius, you could fill the cone up 3 times and pour it into the cylinder, and then the cylinder would be full. No one's going to do it, but whatever. All right. This is just a good demonstration on why it's a third of the cylinder. I like to show this because if you can just realize that if you can figure out the area of a circle, then you can find the volume of a cylinder from there, and then from there you can find the volume of a cone, which I think is pretty nifty. Lots of words here. The volume of a cylinder with height h and radius r can be found using this formula. Okay, we already knew that one. Find the volume of a cylinder with radius 7 feet and height of 20 feet. So this is the volume for a cylinder. The volume is pi times the radius squared times the height. And in this case, they give us both the radius and the height. So this sets up pretty well for us just to plug this directly into the calculator. And pi times 7 squared times 20, 3078.76, that's rounded already. But it's feet, since it's volume. So from what we did before, area is just 2-dimensional, length and width. This one has 2 radiuses and a height, which is 3 dimensions. So it's cubic feet, which you could also write as cubic feet like this. But let's look at the volume of a cone now. So the volume of a cone, you could write it either way. I like this way myself. Pi times the radius squared times the height. Now again, that's a cylinder, but we're going to cut it into 3 parts. That's equals. And all I've got to do is figure out what the radius and height are, which they told us. The radius is 9 feet. And then the height here is 8 feet, so I'll replace the height with 8. Now again, I like this because I can punch it pretty directly into the calculator. Some of you with older calculators may have to use parentheses on the numerator, just so it knows to do that first. Let's see what we get. Yeah, that's in cubic feet, or you could write feet cubed, either way. Suppose that a cliff diver's height in feet after t seconds is given by this model. Find the height after 2.35 seconds. All right. Find the height after 2.35 seconds. Let's look at the formula they gave us. T represents the time in seconds, which it says up here, and we know how many seconds we want to figure out the height for, and that's 2.35. So I'm just going to replace all the t's and not the plus symbols, with 2.35. Well, now that I have this, actually, I can plug it directly into my calculator, and it will tell me the answer. So let's go ahead and do that. We could write this in function notation, the height at 2.35 seconds. You don't have to. I'm sure the homework will put it in for you. So the cliff diver with this model of height after 2.35 seconds would still be 26.44 feet off the ground. Solving equations for a specified variable. Now this looks like it's super complicated, all right. Clear the equation, I'm not even going to use that terminology. It's just very formal, okay. What we got to do is, just like we would with an equation, but now we're solving for a specific letter now, or variable. What you want to do is move everything, let me start that over. You want to move all of the variables that you're solving for on one side, and everything that doesn't have it on the other side, right? Then after that, you would usually just divide, or you would combine both. You would combine like terms and then divide by the coefficient of whatever the unknown is. Now that is also confusing because it sounds weird. However, if we look at it in these terms, let's look at an example of this, and we'll compare them side by side actually. All right, so if this was an equation, you'd know how to solve it, right? But let's look at this using just variables. So this is kind of comparable, the two equations, right? Now you know how to do the one on the left, and the first thing you would do, well you guys would do, is move the x's to the left, correct? Which we can do. So if that were the case, you would subtract 9x from both sides. Now if we can just remember the purpose of this, then solving these or manipulating these other equations isn't too bad, all right? So if we did that, you'd get negative 6x, but you'd still have, plus the 4 equals negative 7, right? It's going to work the exact same way on this other one, except for we got to be careful with the q and j stuff, all right? So I'm going to do the same thing. I'm going to subtract jv from both sides. I apologize. I meant to make that an x right there, just so it's comparable. I apologize. So it's jx, that's better. Okay, well here's the problem is I've got q minus j in terms of x's, right? But I don't know what either of those quantities are, so I just have to represent it as the coefficient of x. It'd be q minus j right there, because I can't quantify that yet. But just like the other equation, everything else stayed the same. I've got plus v, and this equals a negative c. In reality, the equation on the left there, we are manipulating for x. Well, what would we do at that point? You would probably subtract 4 from both sides, right? And you'd get negative 6x equals negative 11 now. But we can do it with the other equation as well. I can subtract v from both sides. Now negative c and minus v are not like terms, so I have to keep those separate. Negative c minus v. And this equals, it's still q minus j times x. Now, to solve for x, I would divide both sides by negative 6, and I would get x equals 11/6. Same thing on this other one. I'm just going to divide by the coefficient of x, which in this case is q minus j. So I'll divide the other side by q minus j, and anything divided by itself is 1, which is what I want, x, 1x. And this is now just negative c minus v over q minus j. That's it. Use principles of equality as though you were solving for x, but mostly with variables. That's what we just did, right? I like that explanation better. So we got these three equations. Circumference of a circle is 2 pi times the radius. Or, yeah, whatever. C equals 2 pi r. Solve for r. All right, we'll do number 1 up here. I've got circumference equals 2 times pi times the radius. Now I've got 2 pi of these radiuses. So I'm going to divide both sides by that 2 pi to make it a 1. That's better, I guess. So I've got 1 radius equals the circumference divided by 2 pi. So now you know if you ever need a circumference of something, I'm sorry, the radius, just take the circumference and divide it by 2 pi. All right, next up, I've got number 2 at 2x plus 3y equals 17. This is a standard form linear equation, which we'll see a lot of. It says to solve for y, so I want the y's on one side of the equal sign and everything else on the other side. This 2x does not have a y, so I've got to get rid of it. I'm going to subtract 2x from both sides. Now 17 and 2x aren't like terms, so I'm going to keep them separated. 17 minus 2x now equals 3y. But I don't want 3 y's, I only want one of them, so I'm going to divide both sides by 3. And y equals, we can just write it just like that, 17 minus 2x over 3. And we have solved for y. Simple interest is principal times the rate times the time. Not that most people use simple interest anymore. But in any case, I equals P R T. We're solving for R in this case, so I don't want the P or the T there. Now this is all multiplication, so to get rid of it, I would have to divide by P. But I would also have to divide by T. See, that's going to cancel those out as 1s, which leaves me with just one rate equals the interest divided by the principal times the time. There it is. Solve the formula. Heat equals circle pi for H. Okay. All right, we are solving for H, so I'm just going to divide both sides by heat. All right, so the E's, A's, and T's become 1s. 1 times 1 times 1. It's just 1. 1H equals circle pi. Eat circle pi. Okay. Solve for B. Bacon equals dinner. For dinner equals yum. Okay. I do like bacon. And we are solving for B, so this whole plus for dinner stuff, we don't want it there. So we're going to have to subtract for dinner. But we do need to subtract it from both sides. And it is not a like term with yum. So here's what I got now. All right, now what would I do? I would divide both sides by, I would just divide both sides completely by Aiken. So B equals yum minus for dinner. Ooh, that looks bad. Minus for dinner over Aiken. Bam. L equals CA plus 3n minus 4 times F. And we are solving for F in this case, so I don't want that CA right there. I want it somewhere else. So I'm going to subtract CA, just to start off, from both sides. L minus CA, there on the left. And I can't combine those two because they're not like terms. So now I've got L minus CA equals 3n minus 4. That's in parentheses, which we do need, times the F. Now I did that kind of prematurely, just because I should show this. Some people choose to distribute the F, but I would not recommend that because then you have 2 F's. Let's just keep it at 1, all right? Because then it's easier to deal with. Here's why, because this next step, I would divide both sides by 3n minus 4. You can put it in parentheses if it makes better sense. 3n minus 4, but I got to do it on both sides. So I've got L minus CA all over 3n minus 4. See, because those cancel out as a 1. 1 times F is just F. We did it. Solve 5p minus 7w equals 14y minus 2, 4p. All right. Well, the p's I want on their own side of the equal sign. That's kind of sloppy, but So I'm just going to have those 5 p's, which means I don't want that negative 7w. So I have to make it a 0 by adding it to both sides. Plus 7w. And it is not a like term with either of the two terms, 14y or negative 2. So I've got 14y minus 2 plus 7w. Next, to solve for p, I would divide both sides by 5. Now look, if you don't like it all over 5 for some reason, and you like to write a lot, you have to split it up into 3 separate parts over 5. Now, I don't remember which way the homework likes it, but I can tell you that I like it a lot like this. Again, that's because it's a lot less writing. Well, not a lot, but it's some. And I am that lazy.